just a little bit about teaching in context. Just a little bit about teaching in context, which we've talked about over a little bit over the course of the syllabus discussions. So I talked about it in the introduction to the syllabus earlier. This is one of the interesting bits about the Queensland syllabuses, senior science syllabuses. The 2006 draft required everything to be taught in context. That is, every physics concept required would be taught in the context of some real world situation. So that might be relatively easy for some of the motion stuff. It might be still relatively easy for some of the electricity and magnetism pieces. It might be quite a bit tougher for the radioactivity. It might be very difficult indeed for quantum and relativity, which we'll be talking about in the rest of this module. So in the end, that approach was discarded, the approach of teaching everything in context. It turned out that to fit the content into the context, you needed too big a hammer. You needed to really distort and make it into inauthentic and fake to say, well, we're kind of studying this context or this content in this context, but really it's a bit of a stretch. So the current syllabus instead says 1 unit in year 11 and 1 unit in year 12 must be taught in context. You can do more if that's helpful, and there are a variety of ways that you can do that. New Century Senior Physics, which I think I've recommended to you before, is a fantastic Queensland textbook that places things in context. It does the entire syllabus in context. I mean, you could do that still if you want to, but you probably are going to run into the same kind of issues that the people testing it in 2006 ran into. That is, that it doesn't seem real to the students, it seems kind of fake, and it also is difficult to cover all of the content and make sure that the students actually understand it deeply. When I was talking about assessment and EEI specifically, something that I meant to say and didn't was this idea that I think a lot of teachers have the misconception that an EEI is a time for students to learn by inquiry, by discovery learning, new physics content. I have seen that happen a lot in schools, and I haven't seen it being terribly effective. I think you'll find that in general, students will be picking up misconceptions or learning about things other than the relevant content. It'll be patchy across the class because they will take on different topics and take different tacks to them. So the kind of content knowledge they develop will be quite different across the group. So I would encourage having them, doing a unit, having them learn the relevant too many very similar words starting with contexts, concepts, and content. I would have them learn the content, learn the key physics concepts ahead of time. And then the EEI is a time for them to demonstrate the skills component and to develop the skills component, not for them to develop the content component. They will clearly learn more about the content. They'll process it more deeply and retain it better because they've done it. But I don't think that they're going to develop that content knowledge from scratch if they know nothing about it through the medium of an EEI. And it's not what it's for. It's not what it was designed for. It's for that investigative process. On the other hand, for contexts, learning in context, so your amusement park physics, which as I might have mentioned already, I think is a very often used one because it has nice motivational effects, but maybe not such an effective learning experience. Depends how it's used, like everything. Or whatever other context you use. Formula One tires and why they're slick rather than bald, or a huge variety of other possible contexts that we can use in physics. Household electricity transmission and whether we can get a higher temperature superconductor, or a whole variety of possible things. Students can learn new content through the context. They will, because they're engaging with it deeply and coming to understand it. They will also learn content that's not on the syllabus by the nature of the thing. Just trying to think of a good example from physics. In amusement parks, you might learn something about break-even points for a ride. When is it too expensive to keep the ride running because not enough people are riding it? You might learn something about that. It's not on the syllabus, but it might be relevant to making judgments about how often something's maintained and therefore how efficient it is, or, whatever you do in a particular context, you're going to learn some things that aren't the content that's on the syllabus, but I'm just encouraging you to be careful to not allow that to override, so that they're learning so much sort of esoteric detail of the particular context that they're not learning any physics. The goal of learning in context is learning physics in context, understanding the concepts, applying them to the real world, and so on. And so making sure that physics learning stays as the focus is, I guess, one of the keys to learning in context.